Hello friends, this video on Haloalkanes and Haloarenes part 32 is brought to you by examfear.com. No more fear from exam. Let's take some examples. The first one, you have to convert ethanol to butane. So if you see, the way it works is, this is my ethanol, that is CH3, CH2OH, and this is my butane. So let me draw butane. CH3, CH2, C, triple bond, CH. So if you see, it has 2 carbons, it has 4 carbons, so you have to add carbons. So one option is, you can convert this alcohol to any aldehyde, and then if you can somehow get this guy, CNA, this will be a very strong nucleophile, and with that, if we react this guy CH3, CH2X, any alcohol, we can get this product. So let's do that. Let's convert this alcohol to haloalkane. So let's convert this. We have CH3, CH2OH. We have so many ways to convert this. I can react this with guy HI. Then since I minus is a very strong nucleophile, with SN2 reaction, what will happen is it becomes C2H5I. Correct. This is one way of converting into my alkyne. And then what I can do is, I have my haloalkane. On this, I need this guy. So let's prepare this first. So prepare this. Let's take this ethyne, and on that we have to add NaNH2 in presence of NH3. What it does is, it gives you this compound. Correct. It's a very strong nucleophile, and this I'll react with C2H5I. On reacting with this guy, since it's a very strong nucleophile, it will replace iodine and it will form butane, and this reaction will be SN2 reaction. Again SN2 reaction, because very strong nucleophile replacing iodine. Correct. So instead of C2H5I, we could have also formed C2H5Cl. So in that case, what was required was, we could have taken this guy and we could have reacted this guy with SOCl2. So we will get C2H5Cl and SO2 gas and HCl gas. And this is a very good reaction, because sulfur dioxide, right, can easily evaporate, and we'll get C2H5Cl. So you can easily separate these guys and we'll get C2H5Cl. It's chloroethane. So anything you can do, if you take C2H5Cl, then you can react C2H5Cl with this compound. So you'll end of the day, you'll get this product. This is done. Let's try this. Ethane to bromoethene. So I have ethane, that is CH3, CH3. I had to form bromoethene. Correct. That is CH2 double bond CHBr. This is ethene, bromoethene. Here also there are various options, right? One option is, you can, since it is we don't have any free halogen here, let's add some halogen, because then only we can do some elimination here. Correct. So let's add so let's do one thing, CH3, CH2. Let's add a bromine free radical in presence of sunlight. It will replace one of the hydrogen, so it will become CH3, CH2Br. Let's add one more, because we have to add double bond and Br, so let's add one more actually, bromine in presence of sunlight. Again free radical reaction, both are free radical reaction. So what we'll get is 2 products. Either it can replace this hydrogen or this hydrogen. So if it replaces this hydrogen, you get this product, or if it replaces this hydrogen, you get CH3, CH, Br and Br. Now what I have to do? I have to do dehydrohalogenation. Correct. So I can do either, I can react this guy with NaNH2, or I can react with alcoholic KH. Right? In both cases, will have a E2 reaction, actually E2 reaction, and will remove this HBr, one of the HBr. So what we'll get is CH2 double bond CHBr. So one Br and one H from this will be replaced, and you'll get this compound. Correct? That's how you get. Or one other option is, once you have done this one bromination, so don't do the second one, just here only you can do alcoholic KOH and heat. You can make CH2 double bond CH2. So once you have got this, right, you can add bromine in presence of CCl4, Markovnikov rule. So you'll get CH2 Br CH3. Sorry, you can just add HBr here. You can just add HBr here. In this, you can just add HBr. So you'll get CH3 CH2 Br. So that's how you get it. Let's take another reaction from propene to 1-nitropropane. So what is propene? Let's see this. CH3 CH double bond CH2 with it propene. It's propene to 1-nitropropane. So let's see what it is. 1, 2, 3, and nitro. This is nitropropane. You can add extra hydrogen. This is what you want to add. So here you have to add nitro group, and there's a double bond, right? So what we can do is, we have to add nitro group, but directly we can't add nitro group, right? And also nitro group has to be added in the last. If I do a nitration, nitro group will be added here, correct? Because of Markovnikov rule. But we have to add in the last, so we can use anti-Markovnikov rule. But anti-Markovnikov rule we can use only for HBr. So let's do anti-Markovnikov addition of HBr in this, and then we can replace the HBr with HBr in the presence of benzoyl peroxide, right? It will be a free radical reaction. What you will get is CH3 CH2 CH2 Br. We have seen this kind of reactions, right? If you have doubt, you can see the past videos where we explain the mechanism for this reaction. And then what we can do is we can just have AgNO2. So this will be SN2 reaction, because this NO2 minus will replace this Br, and what you will get is CH3 CH2 CH2 and NO2. This is 1-nitropropane. So this will be my SN2 reaction. Let's see the other one. Toluene to benzoyl alcohol. What is toluene? This is my toluene, that is a benzene with a CH3. And I have to convert this into benzyl alcohol, that is CH2OH. So directly toluene to benzyl alcohol is difficult. If we can just replace hydrogen with some chlorine, and then we can replace chlorine easily, right? Because hydrogen is not that great leaving group. So we can just do one thing, we can replace hydrogen with chlorine. So to do that, what we can do this, we have this CH3. Let's add this chlorine gas in presence of sunlight, and let's add some heat. So it will become CH2Cl, right? CH2Cl is a free radical reaction. Now what we can do is, we have to go make it OH. So we can just use NaOH, it's a strong base. This is my benzyl chloride, and with that OH minus will replace this chlorine, and you will get this benzyl alcohol. Right, this is benzyl alcohol. Or directly in this you can just add H2O directly instead of NaOH. This, in that case also you will get the same product. Correct? This will be SN1 reaction because the nucleophile is not strong. And this will be SN2 reaction actually, because the nucleophile is strong here. Let's see more example from propene to propyne. So what is my propene? Propene is meth-ith-prop, the double bond, to propyne, that is meth-ith-prop with a triple bond. Right? So we have to add one bond here. There is no polarity, so let's add polarity by adding some bromine, chlorine, or anything. And then once we have this bromine here, right, what we can do is we can do a dehydrohalogenation. So let's do that. So I have a propene. In that, let me add bromine in presence of CCl4. It's addition reaction, right? So what you get is CH3, C, C, and there are 2 bromine here. Correct. This is 1,2-dibromopropane. And on this, what we can do is, one is directly we can react with NaNH2, that is a strong base, with NH3. So it will remove both HBr, 2 HBr it will remove, minus 2 HBr. Then this is the even reaction, actually, elimination reaction, very strong base. This will give me directly CH3, C, triple bond, CH. Or if you want to do in steps, what you can do is, first you can react with alcoholic KOH, right? It will be E2 reaction, and this will eliminate only 1 HBr. This you'll get, and then you can react this guy with a strong base, that is NaNH2 with NH3, right? And then you'll get this product. This is propyne. So we can do any of this directly. You can use NaNH2 and NH3. You remove both HBr in one go, or you can use alcoholic KH, that will remove 1 HBr, and then you can use NaNH2 and NH3 to remove another HBr. So let's see, from bromomethane we have to create propanone. So this is my bromomethane, CH3Br. From this I have to create propanone, CH3, C double O, CH3. So in this case, you see, we are increasing the number of carbon, right? So what you can do is, first you can create this MgBr, this Grignard reagent, and then we can react with CH3COH. So let's see this, CH3Br. Let's react with magnesium in presence of ether, because this is a you get CH3MgBr, right? And then on this you add this acetic acid, sorry, CH3COH. Now what will happen is, if you see CH3MgBr, this is a very strong nucleophile. This is minus and this is plus, right? So this guy will attack this carbon and this will go for minus. So what this you'll get is CH3C, you'll get O minus, there is H here, and CH3 will come here, right? This is nothing but my nucleophilic addition reaction. Now on this you add water, so this will become HOH. So you get CH3COH, H and CH3. Now you can do reduction using copper and heat. Best way to do reduction. With this you will get this product, CH3CO, CH3. Let's see the other one, but1ene to but2ene, right? So let me draw the shape. So what is but1ene? That is 1, 2, 3, 4. At first position I have double bond. I have to convert into but2ene. That I have to shift the position of double bond. Sorry, not this. It will be here. That's what I have to do. So let's bring polarity first, and what we can do is, we can add HBr to it, correct, and then we can do a reduction, or we can directly add water to it and do a reduction. So let's see this. Let me add the first step. So let's add HBr to it, normal addition. So it will become something like this, correct, 2-bromobutane, and then you can do a minus HBr. How you will do that? You can add alcoholic KOH and some heat. There will be E2 reaction. It will form what? This Br will go, and this carbon has 2 hydrogen. This has 3, so this hydrogen will go from this carbon, right? This is beta carbon according to the rule. So it becomes C double bonds. This is what you'll get, and this is my output required. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.